Greetings all, and welcome back to Math in Anger. This is episode 40, and today we are looking at the greatest common factor. But before I do that, please, everyone, in episode 16, I introduce you to this triangle. In episode 19, I show you how to do multiplication tables through calculation. In episode 20, I show you how to do multiplication the understandable way. In episode 37, I show you what a factor and a multiple is. In the previous episode, episode 39, I show you how to do prime factorization. If you don't have that already, if you did not go through those videos, you're not going to understand what I'm doing here. Please don't waste your own time. Go through these episodes one at a time, follow them in sequence. There's a reason I do it this way. For everybody else who has already gone through the videos, let's carry on with greatest common factor. Right. You now know from previous episodes that your additive here is a factor of your product, and your product is a multiple of your additive. Your repeater is a factor of your product is a multiple of your repeater. All right? So let's go and calculate the greatest common factor for some values here. Let's take 24 and 36, right? Watch what I do. The first thing I do is I go and do the prime factorization for each of them. So here's 24. I'm going to do the prime factorization for it. That's 12. That's 2, 6, 2, and 3. So the prime factorization for 24 is 2 times 2 times 2 times 3. And now I'm going to do the prime factorization for 36, right? And that, again, it's an even number. We can do 2. That leaves us with 18. 2, that is 9. Can't do 2, can do 3. 3 goes there. There you go. So the prime factorization for 36 is 2 times 2 times 3 times 3. And now I have our prime factors for each of these values, 24 and 36, right? And now I'm going to take a look at what prime factors appear in both of these. We can see 2 appears here and there, so 2 appears. 3 appears here and there, so 3 appears. And then I'm going to take the least amount of times that each factor appears. Here we have 2 appearing 3 times. Here we have 2 appearing 2 times. So I'm going to write 2 down twice. Here we have 3 appearing once, and here we have 3 appearing twice. So I'm going to write down 3 once. There we go. 2 times 2 times 3. That is going to give me my greatest common factor. And 2 times 2 times 3 is in balance with 12. So, yeah, that's great. That gives me the greatest common factor. But I want to point out something to you guys. Watch what happens when I do the table, the multiplication table for 12. Watch this. So we've got 12. In order to find out what 2 times 12 is, that is 12, and 12, that is 24. We can do 4 quickly. Guys, if you don't know what I'm busy doing, please, you need to go and watch the episode on multiplication tables through calculation, okay? Right, and that's 24 and 24, that is 48. I can do 8 quickly. That is 48 and 48. That is 69. There we go. Now we can do 3 quickly. That's 3. It's 24 and 12. That's 4, 5, 6, and 3. Now, hold on. Wait a second. Look at that. Look at that. See, I don't even have to calculate any further. What I wanted to demonstrate to you is that your greatest common factor, the question that's actually being asked is, what is the greatest additive that you can go and calculate a multiplication table for that has both these values in it? Do you see that? That is how the greatest common factor ties back to your multiplication table. But okay, great. So we have this, but where's this useful? Where is this in any way actually something that you'll use? Well, the first place you'll use it in school is with fractions. Like, take a look at this. If you have two fractions like 8 24ths and 15 36s, right? Now, you can't add those two together because your additive is different for both of them. There's no way to make sense out of that. But you have a factor that is common to both of those, right? To both your additives. So you can go and rewrite these fractions as something that is related to that factor, right? So let's see. 8 24ths, that would be how many 12ths? Well, how many times does 12 go into 24? Twice. So what is 8 divided by 2? It is 4. So 4 12ths is in balance with 8 24ths. And now we can do the same thing for 36. How many times does 12 go into 36? 3 times, right? So what is 15 divided by 3? That is 5. And now you can go and write that as a single fraction, which is 4 plus 5 is 9 and 12ths. That is 9 12ths, right? But with a little bit more brain work, you can go and see, but hold on a second, both 9 and 12 is divisible by 3. So, what is 9 divided by 3? Well, that is 3. And what is 12 divided by 3? That is 4. So this whole business, this whole mess that I could not make sense of is now just saying, well, it's in balance with 3/4. And that's one of the things that we use the greatest common factor for. It is to rewrite fractions in a way that is easily readable and understandable. Right? But I'm going to do another example for you, and I'm going to do it with some notes so that I can get this down for you guys quite solid. With respect to greatest common factor, there are things that we use it for outside of fractions, but we'll get there quite a bit later. Right now, I'd like you to take a look at this. This is a very formal definition for what the greatest common factor is, right? The greatest common factor of 2 or more values is the greatest natural number, this is important, the greatest natural number that can divide all the values that you are working with without having a remainder for any of them. Okay? And again, all it boils down to is what is the biggest additive that you can have, that you can calculate a multiplication table for, that works for all the values that you're working for. And yes, you can do the greatest common factor calculations for more than one value. Well, for more than 2, sorry. At school, it's typically only 2. But yeah, it becomes useful in other cases as well. Let me just move this out of the way. Let's put it over there. And then and I go and fetch you the steps that I did. There you go. Write this down. Pause the video, write this down. These are the steps that you follow in order to get your greatest common factor for any number of values. And for this example, we are going to use, let's say, 110 and 132, right? So let's write the prime factorization for all values. Let's go do that. So 110, that is even, it's divisible by 2, that leaves us with 55. We can't do 3 here, we can't do 2, but 5 will, and that gives us 11. So our prime factorization for 110 is 2 times 5 times 11. All right? Now let's go and do that for 132. That is even. We can use 2. That leaves us with 66 on this side. Still divisible by 2. That leaves us with 33. Can't use 2 here. 3 will work, and that leaves us with 11. And there we go. There's our prime factorization. And this then is 2 times 2 times 3 times 11. Right, so that's our prime factorization for 110 and 132. There we go, that's step 1. Then we find the prime factors that are common among all the factorizations you did. So 2 appears in both, 11 appears in both, 5 only appears here, so we can't use it. 3 only appears here, so we can't use it. So then we find the least amount of appearances for each of the common prime factors. What is the least amount of times that 2 appears? Only once, right? What is the least amount of times that 11 appears? Only once, right? So we did this, we did this, here we go. And that gives us 22. And now I'm going to do the 22 multiplication table just to bring this back to multiplication for you. This is 22. That is 24. Sorry, that is 44. 4. That is 44. 44. It's 88. 8 is going to be this. That is 16, 17, and what's it going to be? 3. That is 44, and 22. That is 66. 5 is going to be 2. That's 110. And let's just make some space here. Move that over. We have 6. That is going to be double whatever 3 was. Oh, hold on a second. Watch this. 110, 132. 110, 132. Do you see, again, the greatest common factor is asking you, what is the additive? What is the biggest additive that you can use to make a multiplication table that has both the values here? Do you see it still comes back to your multiplication table? That's all it is. Right. But now you know the greatest common factor. Now, well, you know what the greatest common factor is. You know that it ties back to your multiplication tables. And you know that one of the things we use it for is to write fractions in simple form. There are other things that we can use greatest common factor for, but those are the two things you will run into at school. Right. What else can I say here? No, I think that's about it. This then was Math in Anger, episode 40. Ladies and gents, boys and girls, everybody in between. This is not nearly as difficult as you think it is. I hope you learned something. I'll see you in the next one. Ciao.